Hi class. Today's lesson is 9.1, which is solving equations by taking the square root. Our essential question for this lesson is how can you use completing the square to solve a quadratic equation? We'll find that out within the lesson. Our objectives today are students will be able to complete the square in a quadratic expression to reveal the maximum and minimum value of the function it defines. Your language objective is students will explain to a partner how to complete the square of a quadratic equation in the form of ax squared plus bx plus c equals 0, which is our standard form. Completing the square is a process of rewriting a quadratic expression as a perfect square trinomial so that it can be solved by taking the square root. For 9.1, we'll only be looking at when a is equal to 1. That's our a value, the coefficient that's in front of our x squared, when it is only 1. We will not look at it when it's greater than 1. So for example 1, we're to complete the square to form a perfect square trinomial. For a, we're given x squared plus 4x. To complete the square by adding half of b and squaring it. So what we're going to do is take our b value and substitute it into this equation, which we have to the right in red, which is b divided by 2 squared. So our b value here is 4 because it is in front of the x. Again, our b value is the coefficient of 4. So in our equation, we'll substitute 4 for b, which would give us 4 divided by 2 squared. In which case 4 divided by 2 is 2, and then we would square it, in which case 2 squared is 4. So all we did was take our b value, divide it by 2, and square it. That allows us to complete the square and create a perfect square trinomial of x squared plus 4x plus 4. We're going to try a new example. Again, for example 2, we're going to complete the square to form a perfect square trinomial. Our example B has x squared minus 8x. Again, to complete the square by adding half of b and squaring it. We're just utilizing the equation b divided by 2 squared. So we have to identify our b value here, which is negative 8. So we would take negative 8 and divide it by 2, then square it. If we were going to divide negative 8 divided by 2, we would get negative 4. And then we would square negative 4, in which case negative 4 times negative 4 is 16. All we would do is now recreate our equation of x squared minus 8x and add 16 to it. That would be us creating a perfect square trinomial. This is our third example, in which case I want you to give it a try. But again, we're just completing the square to form a perfect square trinomial. So we're given the equation x squared plus 12x, in which case my a value is still 1 and my b value is 12. Go ahead and utilize our equation b divided by 2 squared. I'll give you a moment. What you should have got for our b is 12, so we utilize our equation 12 divided by 2 squared. In which case we want to simplify what's inside the parentheses. 12 divided by 2 would give us 6, and 6 squared would be 36. So now all we would have to do is rewrite this in standard form. Again, ax squared plus bx plus c. In which case, we would have x squared plus 12x plus 36. That would be our new format of a perfect square trinomial, where we completed the square, again by taking 12, our b value, dividing it by 2, and squaring it. I have a critical thinking question for you. In which case, when b is negative, why is the result added to the expression still positive? Why would that be? Again, our equation is b divided by 2 squared. Well, if I had to think about it, it cannot be negative because we are adding half of b and squaring it. Any number squared cannot be negative because a positive times a positive would give us a positive, and a negative times a negative would give us a positive as well. So we would be adding a positive number for c every time. We had some good practice in finding our C value, and creating a perfect square trinomial on expressions. Now we want to be able to solve by completing the square. So it says across the top, solving x squared plus bx plus c equals 0 by completing the square. So for example 4, we're going to solve by completing the square and check our answer. So for example D, we have x squared minus 2x equals 3. To the far right, we see a flowchart. That flowcharts are just steps to find and solve for x. So first, I want to find my b value and divide it by 2. Again, my b value will be the coefficient in front of the x, in which case it's negative 2. I want to utilize again my equation for my c, which is b divided by 2 squared. So I substitute negative 2 in for b, in which case I get negative 2 divided by 2 squared. I want to simplify what's inside the parentheses. Negative 2 divided by 2 is negative 1. So now I have negative 1 squared, or negative 1 times negative 1, which gives me 1. Our second step is to square this value, which we just did. We found 1. And now we need to add it to both sides of our equation. We're going to add it to the left side to create a perfect square trinomial. And we're also going to add it to the right side, which is 3. So I should have x squared minus 2x plus 1 equals 4. Now for my third step, I'm going to factor the left side of the equation. Again, we can factor by using the area model, the big X, or because I know it's a perfect square trinomial, it's going to create two of the same binomials, in which case I know it would be x minus 1 times x minus 1 equals 4. And again, since I have the same binomial twice, I can condense this to x minus 1 squared equals 4. Again, I need to use the sign of my b value. That's why it's a negative 1. And I know that it has to be 1 because only 1 plus 1 can equal 2. So now I've factored my left side of my equation. Now I need to solve for x by step 4, taking the square root. Since the left side of my equation has an exponent of 2, I need to simplify that side by doing the opposite of an exponent, in which case it's squared, by taking the square root or using a radical. And if I'm going to square root the left, I must square root the right. If I square root the left, that cancels the exponent of 2 out. All I'm left with is x minus 1. And if I took the square root of 4, I know I should get plus or minus 2. Again, 2 times 2 is 4, but also negative 2 times negative 2 is also 4. So I need to represent that as two different solutions of plus or minus 2. I still haven't solved for x yet because I still have negative 1 on the left side of the equation. And so what I must do is to solve is create two separate equations in which one equation is x minus 2 equals the solution of 2, and x minus 2, or x minus 1 equals the solution of negative 2. And I must solve for x for both equations. For the top one, x minus 1 equals 2, I have to use the inverse operation of subtraction, which is to add 1 to both sides. That cancels the left side of negative 1, but on the right, I have 2 plus 1, which would give me 3. So one of my solutions is x equals 3. My right, the equation below it, x minus 1 equals negative 2. I still have to use the inverse of subtraction, which is to add 1 to both sides, in which case I would get x equals negative 1. I have now solved for x and found my two solutions, 3 and negative 1, which are my x-intercepts of this quadratic. Let's look at another example. Again, we want to solve for x squared plus bx plus c equals 0 by completing the square. Again, we're trying to find our x-intercepts by using the method of completing the square. For this example, I have solved each by completing the square and checking our answer. So our example has x squared minus 10x equals 11. Again, my first step is to identify my b value. My b value here is negative 10. I'm going to take negative 10 divided by 2 and square it. So I'm going to use my equation b divided by 2 squared, in which case I want to simplify what's inside the parentheses. Negative 10 squared is negative 5. So negative 5 squared, or negative 5 times negative 5, gives me a positive 25. Again, looking back at that flow chart, we know that our second step is to add that c value we just found to both sides of our equation, because again, what I do to one side, I do to the other. So I would have x squared minus 10x plus 25 equals 11 plus 25. I should have, again, 36 on the right, but we'll look at that on our next step. But again, step 3 was to factor. So if I was to factor the left side of the equation, I can factor by using the area model, by using the big X method, or by knowing that it's a perfect square trinomial. Again, I'm going to take my b value sign, a negative, so I should have two binomials of x minus, and the number would be, in this case, half of 10, which in this case would be 5. So I should have x minus 5 times x minus 5 equals 11 plus 25, which is 36. Again, I want to condense those two binomials that are the same as a squared. So I would have x minus 5 squared equals 36. Now I want to take the square root to eliminate the exponent on the left side of the equation. And if I'm going to square root the left, I must square root the right. So square root the left and right. And now the square root and the exponent on the left side of the equation cancel, in which case I should have just x minus 5. And the square root of 36 is plus or minus 6. Again, x is still not by itself. It's still not isolated. So since I have two different solutions of positive or negative 6, I need to create two separate equations. One in which is x minus 5 equals 6, and one in which is x minus 5 equals negative 6. And I must solve for both. I have to get x by itself. So for the left of x minus 5 equals 6, I'm going to add 5 to both sides because I'm doing the inverse of subtraction, in which case I should have x equals 11, which is one of my solutions. And on the right equation, I'm going to add 5 to both sides, and I should have x equals negative 1. I have found both my solutions of 11 and negative 1, which are also my x-intercepts, or even zeros if you want to call them. We're going to look at one last example. So for this example, again, we want to solve our quadratic equation by completing the square. We have the example of x squared minus 6x minus 2 equals 0. Here we're presented with a c value, but that doesn't allow us to factor it by using the big X method or the area model. So if we're not capable of doing that, we need to first move that c value over the equation so we can find a new c value to create a perfect square trinomial. So my first step here would be to add 2 to both sides, in which case that would cancel the 2 out on the left side of the equation and leave me with x squared minus 6x equals 2. Now I can actually find a perfect square trinomial by taking my b value, dividing it by 2, and squaring it. So I would have negative 6 divided by 2 squared, which in this case, negative 6 divided by 2 is negative 3. And negative 3 times negative 3 gives me a positive 9. So if I was to rewrite this equation, I would have x squared minus 6x plus 9 equals 2 plus 9. And I know 2 plus 9 is just 11. So I have the equation of x squared minus 6x plus 9 equals 11. And again, I could factor the left side of the equation by either the area model, the big X method, or because I know it's a perfect square trinomial, I'm going to take the sign of my b value and half of my b value for my binomial, in which case I should have x minus 3, because 3 is half of 6, and I use the sign of my b value, which is a negative. So again, x minus 3 times x minus 3 equals 11. I first want to condense those two binomials, because they are the same, into x minus 3 squared equals 11. Again, my next step would be to take the square root. I want to eliminate the exponent of 2 by first squaring it. And what I do to one side, I must do to the other. So now what I should have is x minus 3 equals, in this case, I have the square root of 11. Square root of 11 is not a perfect square root. And 11 is a prime number, so I cannot simplify any further. So I just leave it as x minus 3 equals plus or minus the square root of 11. Again, I should have two solutions here, and I need to create two separate equations. I have one in which it's x minus 3 equals positive square root of 11, and x minus 3 equals negative square root of 11. Now I can isolate the variable of x, first by adding 3 to both sides. And I cannot combine the like terms or I cannot combine 3 and square root of 11 because they are not like terms. So I just leave it as x equals 3 plus the square root of 11, and that's one of my solutions. Now I must do that to the other equation. Add 3 to both sides, and I get x is equal to 3 minus the square root of 11. These are my two solutions, or my two x-intercepts. So sometimes our answers are not perfect square roots and have square roots inside them as an answer. I just wanted to make sure I summarized this lesson, in which case, in order to complete the square, I must transform one side of the equation into a perfect square trinomial. Then I must solve the equation by taking the square root of both sides. And that allows me to find the solutions or the x-intercepts for my quadratic equation.